All right. So with that said, let's get into our notes for today. This should be a pretty short note segment today. So anybody that wants to stick around afterwards, if you still have, I know a lot of people still had some questions about the balancing equation stuff from the last couple days. So after the notes today, anybody who wants to stick around and ask me a couple questions about that or about anything that we've talked about in this class so far is more than welcome to. But let's go ahead and get started. So as always, I'm recording our video that we're going through with the notes today. And so if you want to rewatch this video again, see me go back through these notes if there's something that you missed the first time around, it's going to be posted on the October 7th section of Zoom class videos called SI Units and Conversions, because that is what we are going to jump into today. So the first several weeks of our IPC class have all been really focusing on the C side of IPC, the chemistry side. So that's all the stuff with the atoms and the states of matter and the chemical and physical properties and changes and the neutrons and electrons and all that good stuff, the chemical reactions, all of that is the chemistry side of IPC. But we still have that P that we need to get to, which stands for physics. So with the last couple weeks of class today and next week, we're going to be doing a little bit of looking at some different aspects of physics, how physical objects move around the world, how different forces on them cause them to change where they are at. It could be something as small as the atoms that we've been talking about. So there are atomic physicists who study how atoms move around, all the way up to astrophysicists who study the biggest things in our universe, planets and stars and stuff like that. So physics is all about measuring how things move and interact with the world around them. And so because there is so much on measuring, today we're going to talk about the specific types of measurements that we take in science, which might be a little bit different than the types of measurements that you might normally see around you in everyday life. Oh, one more announcement that I wanted to make before we get started for today. Our Monday class is canceled because there is no class on Monday again. We're having another teacher workday in order to prepare for term 2 that we have coming up. So there's not going to be a Zoom class on Monday, and there's not going to be any new notes or assignments posted on Monday. So you guys get Monday off of new stuff. If you want to use that day to work on some old stuff, get caught up on some of your old work, that would be a great use of your Monday. But no class, no assignments posted on Monday. All right, so SI units, scientific units, and how we convert between them. That is what we are going to be focusing on for today. So SI units stands for Standard International Units, but you may have heard them referred to in a different way before with something called the metric system. So the metric system is not only the way that scientists measure the world around us, it's also the way that most other countries measure length and distance and volume and mass or weight compared to how we usually do it in America. So today we're going to talk about what some of the common metric system units are, how they're a little bit different from our American units, and how we can convert between big and small metric units. So the first type of measurement we're going to be talking about is length or distance, how long, how wide, how tall that an object is. So in American units, we have things like miles and yards and feet and inches. But in metric units, we have, you may have heard of these before, kilometers, meters, centimeters, and millimeters. So if we compare them to the units that we already know, 1 mile is about 1.6 kilometers. So 1 mile is longer than 1 kilometer. A meter is just a little bit longer than a yard. So here we have a yardstick down below and a meter stick. Their ends that are cut off on the left-hand side are matched up with each other. And so you can see a meter stick is just a little bit longer than a yardstick. So a meter and a yard are pretty close to each other. If you've ever looked at a ruler before when you're measuring something, you noticed that one side of the ruler has numbers that are more spaced out with our inches. Another side of the ruler has numbers that are closer together, which are our centimeters. So 1 inch from the 1 to the 2 mark over here, that's a 1 inch distance, is about 2.5 centimeters. So we can fit 2.5 centimeters between each inch. And then you can also see on this little ruler picture that we have even smaller units, millimeters, which are every single one of these little dashes in here. So the big numbers are the centimeters. These little dashes indicate the millimeters, just like how up here they represent half inches, quarter inches, eighth inches, stuff like that. And the metric system, we don't worry about that. We just have centimeters, and then smaller than that is millimeters. So you may have noticed a common term used for all these measurements, and that is the meter. So the meter is our basic length unit in the metric system. It's what all the other length units are based off of. So if we go bigger than a meter, we have a kilometer, which is 1,000 meters. So if we took 1,000 meter sticks and stacked them end on end on end, they would stretch out 1 kilometer. And then our meters are made up of lots and lots of centimeters or lots and lots of millimeters. So in one single, I mean, I can show you like this, but it's really like out like this. In one single meter stick, we have 100 centimeters, so centimeters. You notice we still have our meter in there. Or if we go even smaller, there are 1,000 millimeters in a single meter stick. So a millimeter is an extremely small measurement. A centimeter is a pretty small measurement. 1 meter is a relatively long measurement. Again, it's about a yard. And then a kilometer or a kilometer is 1,000 meters in total. So you may notice one of the other really nice things about the metric system that we're going to talk a lot about when we get to converting between our different units is that all of these are base units of 10 or 100 or 1,000, right? It's not like the English system or the American system where we have a mile, and a mile is 1,300 yards, or it's 5,280 feet. And then each foot is 12 inches, and each yard goes into 3 feet. So we've got 12 and 3 and 5,000 and 1,300. There's a lot of different conversions that you have to do to go between them. Metric system, super easy. It's all based on 100 or 1,000. So it makes it extremely simple to convert between kilometers, meters, centimeters, and millimeters, which is something that you guys are going to be doing a lot of for your assignment tomorrow. Talk about that a whole lot more later on in the notes. So if you took out your meter stick and wanted to measure out 1 centimeter, you might notice that there are 10 little dashes in between the 0 centimeter and the 1 centimeter mark. And that's because there's 10 millimeters in a single centimeter. So 1 full centimeter has 10 of our little millimeters in here. So if we were to measure this blue line right here, that'll work. If we measure this blue line from end to end, if we did it in centimeters, we could say, all right, we've got 1 centimeter, 2 centimeters, and then not quite 3, 2, 1, 2, 3, 4, 5, 6, 7, 8, 2.8 centimeters total. Or if we wanted to measure it in millimeters, we could just count up all of the very small dashes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23, 24, 25, 26, 27, 28 little dashes. So we could say that this blue line is 2.8 centimeters long. We could also say that it is 28 millimeters long. Both of those are equally correct. It just depends on what unit that you want to use, whether you want to use the bigger centimeters or the teeny tiny millimeters. All right. Any questions on the metric system or using meters and centimeters to measure length so far? Anything I've talked about that's still a little? All righty. If nobody has any questions at the moment, we will move on. So that's length. We use our base unit of a meter, and then we can go bigger up to kilometers and smaller down to centimeters or millimeters. Up next, we have mass or weight. So again, we're not using pounds and ounces like you might with American weight measurements. Instead, in metric units, you have things like kilograms, grams, and milligrams. So a gram is very small. In 1 pound of an American unit, there are over 450 grams. So a gram is very, 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 very light. It would be like a single toothpick or a single paper clip. That would be about the weight of 1 gram. Kilograms, on the other hand, are relatively heavy. So a kilogram weighs a little over 2 pounds. So if you meet somebody from England and Australia and they describe their weight as being 100 kilograms, it's not because they're a small, skinny person like we would think if they said they only weighed 100 pounds. In reality, these people would be fairly stocky depending on their height, because 100 kilograms is 220 pounds. So a kilogram is pretty hefty. I don't know why somebody gave this example to me when I was younger, and it always stuck with me. If you think about like a big textbook, like a math book or a science book that you might have used in school back when you were younger, or that maybe your kids bring home from school every now and then and makes their backpack weigh a ton. One textbook is about a kilogram on average. Obviously, some are a lot bigger than others, but if you think about like the weight of a big, hefty textbook, that is about a kilogram. And then obviously, if 1 gram is very light, then 1 milligram is extremely light. So just like with our meters and millimeters, there are 1,000 milligrams in a single gram. So a milligram is an extremely, extremely small unit of weight. It would be like a couple specks of dust would weigh about 1 milligram. So metric system, measuring things using mass, aka the weight of an object. And the base unit, as you may have determined already, is the gram. So again, super simple conversion between our different types of units. We have the gram is a base unit. Then if we put 1,000 grams together, we get 1 kilogram. Or if we split a single gram up into 1,000 individual pieces, it would be, each one of those would be 1 milligram. So there are 1,000 milligrams that go into 1 gram, and there are 1,000 grams that go into 1 kilogram. In measuring weight, we usually stick with kilograms, grams, and milligrams. We don't really get into, like, there's not really a centigram that's really commonly used, unlike with the length of stuff with the centimeters. Centigrams, not really used so much. kg, g, or mg. Oh, that was another thing I wanted to point out, almost forgot, is that you'll notice that each one of our units can be abbreviated to 1 or 2 letters. Usually 1 letter for the base unit. So like gram is a G. Meter, like we talked about earlier, would just be an M. And then if we get bigger and go up to a kilogram, then we put a K in front of it, so it becomes kg. Or if we get a lot smaller and go down to milligram, we put a little m in front of it and it becomes mg. So mg for milligram, g for gram, kg for kilogram. Just like with meters, we had m for meter, km for kilometer, and mm for millimeter. Finally, volume, the amount of space that something takes up. So like if you measure the height, width, and depth of like a piece of furniture, that tells you its volume. Or if you're talking about how much liquid you have, like how much milk you have left in the jug, or how much soda is left in the big bottle, that would also be volume. So in the English, aka American system, we use things like gallons, quarts, pints, cups, ounces, teaspoons, tablespoons, all sorts of stuff like that. In the metric system, especially if we're talking about liquids, we instead use liters. So a liter is very, very close to 1 quart. So if you think about like the quarts of milk that you get at the grocery store, like the super skinny milk cartons, that would be a quart. And then as we talked, as you hopefully remember from like elementary school science, 4 quarts go into a gallon of milk or water or whatever liquid you have. So liters are very, very close to quarts. So 1 gallon is about 3.8 liters. So almost 4 liters per gallon. So a liter, a little bit bigger than a quart, but obviously much smaller than a gallon. And then just like with our other units, we can also measure things in milliliters. So milliliters are very, very, very small. There's almost 30 milliliters in a single fluid ounce. So what this means is in your normal can of soda, you have 12 fluid ounces in that can. If you converted that to milliliters, it would be about 355 mils or milliliters, mLs. So over 350 milliliters in a single can of soda. So milliliters are very, very small. I kind of think of them as like if you take like an eyedropper or you're taking drops of something like some sort of medicine, a single drop is approximately 1 milliliter. So hopefully you figured out that for volume, our base unit is liter, which can be represented by capital or lowercase l. So volume is just the amount of space an object takes up. We can measure volume in terms of its liquid volume. So if we put this object into water, how much water would it take up? How much space would it take up? We can also represent it by cubic centimeters. Or so if you ever see like a CM3, that also refers to volume. That just refers to if you measure a object and you do its height times width times length, you get centimeters times centimeters times centimeters, which is your centimeter cubed for volume. So instead of like cubic feet, like you might describe like a fridge or a piece of furniture, we have cubic centimeters. So just like in our mass and our length, we have liter is the base unit, and then we can go smaller down to our milliliters. We usually don't go up to kiloliters, just kind of standard convention in science says liter is usually about as much that you need to describe. One interesting thing though, is that 1 milliliter of liquid is equal to 1 cubic centimeter. Or another way that people describe cubic centimeters is cc. So if you've ever heard of like medicine, especially if you're at a hospital and you have to be given a certain number of cc's of medicine, that's what they're talking about, cubic centimeters of medicine. So we have our meters, which are used to measure length, our grams, which are used to measure weight, and our liters, which are used to measure volume. We can have things like kilometers or kilograms or milliliters or millimeters or milligrams or centimeters, all sorts of different sizes of our base measurements of liter, gram, or meter. Any questions so far about any of these metric system units? All right, awesome. So this stuff pretty simple, pretty straightforward. We're just talking about making measurements. The next thing is a teeny bit more complicated, but I promise it is much simpler than that balancing equation stuff we were doing last week. And this is doing metric conversions. So if we have a certain number of grams of a substance, what if we want to know how many milligrams that we have? Or if we have centimeters, what if we want to know how many meters in total do we have? How can we convert between our different types of measurements? So I'm going to show you guys a super duper easy way to do these conversions using a system called the ladder method. So how does the ladder method work? It looks something like this. So here is our metric ladder. We have our basic units right in the middle here, our meters, grams, and liters. And then up here, you see our kilo for our kilometers or our kilograms. And down here, you see our milli for our millimeters or milligrams or milliliters. We've also got our centi right here. That's for our centimeters. The other ones that are on here don't really get used as often. You're not going to see very many hectoliters or decagrams or deciliters used in scientific notation that often. It's basically just your base unit, and then the kilo, that's larger, and the centi and milli, that's smaller. But we still include them because they are an important step for doing our conversions. So how do you use the ladder method? First, you determine your starting point. So let's go ahead and start with the example that they give us down here. Let me change the color and make it a little bit easier to see. So we have 4 kilometers. We have measured something 4 kilometers. And we want to know how many meters is that. We want to convert from kilometers to meters. So our starting point is our kilometers right up here. Whoops. All right, kilometers. So we know our starting point is kilometers and our ending point is meters. And so that is our basic unit, our basic metric unit for length is meters. So we're going to start at kilometers and go to meters. And so as we go from kilometers to meters, we're going to jump or step down each level of the ladder. So that's what these red lines here represent. We start at kilometers, and then we do 1, 2, 3 jumps down to our meters, our basic unit down here. So we did 3 jumps, and we did those 3 jumps to the right. Okay, because we started at our kilometer, we had to jump to the right to get to our meters, and we jumped to the right 1, 2, 3 times. 1, 2, 3. So now that we know we have to make 3 jumps to the right, what does that mean in terms of our number? So the third step in the ladder method is you're going to move your decimal point the same number of jumps in the same direction that you jumped. And so we had to do 3 jumps and they were to the right. So we're going to move our decimal point 3 jumps to the right. So we start with 4. So that's what's right here, our 4. And sorry, the kind of spacing got off a little bit weird here. So I'll go ahead and move him up a little bit higher. So we start with 4, and remember from math class, if we don't have any decimals out there already, it's like the 4 has a little decimal right at the end of him. And then we have to move our decimal plates 3 jumps to the right. So that's what the little lines down here are showing. 1, 2, 3 jumps to the right. So now we have the 4 over here, the decimal over here, and we fill in the empty spaces with zeros. So in 4 kilometers, we have 4,000 meters. So 4 kilometers is the same as 4,000 meters. Again, we started with our 4 kilometers. We took our decimal place 1, 2, 3 jumps to the right, filled in those empty spaces with zeros, and determined that 4 kilometers is equal to 4,000 meters. So you determine your starting point. What units are you starting with? Jump to your ending point. So wherever your ending point is, jump and count how many jumps it took and what direction you went in. And then do that same movement, those same jumps and direction with your decimal point. All right, any questions? We're going to do a couple more examples of these. So if you're not an expert on it yet, don't worry too much. But any questions about this ladder method so far? Anybody still not really sure what I'm doing or how I'm getting there?
So I guess we're just using we're going to have to use the ladder method and just start, like you said, 4 kilometers and then start right there. And then you said count the jumps to your ending point. So we'll have to go like, we're going left and right, kind of.
So in this case, our starting point is kilometers and our ending point is meters. So we're going to jump to the right.
Right.
If our ending point was meters, but our starting point was something like millimeters or centimeters, then we'd have to jump to the left. And we'll do some examples of those in a little bit, I promise.
Okay.
All right. Good question to start off with. So I'll do a couple more, or I'll do one more example, ask a question, and then have you guys do an example with me to kind of make sure that we're all on the same page. So here we've got kind of a squished version of our ladder. And so let's see. We'll do this guy right here. So it says that 1.6 liters is 1,600 milliliters. Let's use our ladder method to make sure that is correct. So our starting unit is liters. So that's one of our basic units, right? We've got grams, we've got meters, and we've got liters. So we're going to start with liters. And then milliliters. So our milli units are down here. So to get from liters to milliliters, we have to go 1, 2, 3 jumps. So that's 1, 2, 3 jumps. And we made those 3 jumps to the right. So we're going to do the same thing with our 1.6 liters in the decimal spot. That's it. So I'm going to go ahead and write it down here because it's a little bit easier for me to write in big letters. So we start off with 1.6, and to get to milliliters, we said we had to jump 3 spaces to the right. So we take our decimal place and move it 1, 2, 3 spaces to the right. So we fill in all of our blank spots with zeros because our 6 is here.
Hey, Mr. Stanley, I'm here. I'm sorry.
Hey, Lorenza, no worries. Thanks for joining on.
This will be on our Zoom thing, right? What you've been going over? Okay.
Sure will.
Okay.
So we moved our decimal spot 3 spaces to the right. So now we have 1600 before our decimal. So 1.6 liters gives us 1600, also known as 1,600 milliliters. So I checked and this is correct. We started off with our 1.6 liters. We moved 3 decimal spots to the right, filled in our empty spaces with zeros, and figured out that 1.6 liters is 1,600 milliliters. All right, so that's how we go to the right, but what if our movement, what if our jumps to the left? Erase all this stuff over in here. So let's look at another example. Let's look at this guy. We start off with 109 grams, and we want to see if that does in fact equal 0.109 kilograms. So our starting point is our gram, our basic unit, and our ending point is kilograms, which is over here. So to get from grams to kilograms, we're going to have to go to the left. And we're going to have to go to the left 1, 2, 3 jumps. That's a 1, 2, 3 jumps. So to convert from grams to kilograms, we're going to have to move our decimal point 1, 2, 3 spaces to the left. So we have 109 grams. And again, if it's just a whole round number like that, the decimal point is at the very end of it. So we said 3 spaces to the left. So let's see. If we take our decimal point, 1, 2, 3 spaces to the left. Now our decimal is in front of the 1. So we have 0.109. So indeed, if we have 109 grams, that is equal to 0.109 kilograms. So we started off at grams, figured out we had to move 3 jumps to the left. So we took our decimal point at the end of our number, moved it 3 jumps to the left, and ended up with the decimal point in front of the 1. So that gives us 0.109 kilograms. All right, so now that you've seen a couple examples, what are questions that anybody has?
Is the basic unit always measured in grams, or is it whatever you're measuring that you're going to fill in that on the conversion?
It's whatever you're measuring. So our basic unit is our grams or our meters or our...
Just whatever you're measuring then, okay.
Yeah. So like here, over here, we have grams is the basic unit, and then milligrams is the smaller unit, right?
Okay.
Meters is our basic unit, kilometers is our bigger unit. Good question. Any other questions? Anybody still not really sure how I'm converting between our different measurements?
Mr. Stanley,
Yes.
can you do an example of the one you did just before this one? Because I'm driving at the same time. I know I shouldn't be, but I didn't quite get to see how you moved those zeros over.
Sure thing. So, oh, here's a good one that is kind of similar. What if we want to go between 2 units that are not our base units? So say we have 160 centimeters, and we want to see how many millimeters does that give us? So our centimeters, our not our base unit, but our starting unit is centimeters, which is going to be right here. And our ending unit is millimeters, which is right next to them over here. So first off, we got to count our jumps. So from centimeters to millimeters, we're only making 1 jump. And that jump is to the right on the ladder. So if we start off with 160 centimeters, we know we have to move our decimal one place to the right, one jump to the right. So in a number like 160, our decimal comes at the end of it after the 0. We're going to jump it one spot to the right. So now our decimal is further over, and we fill in that blank spot that we just created with a 0. So now we started off with 160 centimeters, and by jumping that decimal one spot to the right and filling in that blank space with the 0, we end up with 1,600 millimeters.
Okay, so wherever we move the decimal at, and there's not a 0 in front of it, we just place a 0 in front of each one that has a spot to be filled.
Mm-hmm.
Okay.
Yeah, exactly. So if there's a number out there already, like earlier we did 1.6 liters to milliliters. And when we moved the decimal one time, the 6 was already there, so we didn't have to do anything. But the other two didn't have a number there already, so we filled it in with the zeros. And that's where those zeros came from. All right, great question. Thank you, Monica. Any other conversion related questions?
Oh, goodness.
All right, so I'm going to do one more example and have you guys kind of help me figure out where to go for this. Let's see. What would be a good example? We'll do two more examples. Okay, 198 grams to kilograms. All right, so for our first example, we have 198 grams, and we want to convert it to kilograms.
Go left.
So if our starting unit is grams, where does that put us on our ladder up here? Where do grams fit in on the ladder?
In the basic unit?
Mm-hmm. Precisely, Belma. So grams are a basic unit. So that's going to be our starting point. And then kilograms are the kilograms to the left or to the right of our grams.
To the left.
To the left, exactly. Our kilograms are way over here. So we've got our starting point, we've got our ending point. We know we're going to the left. So how many jumps does it take to move from grams to kilograms on our ladder?
3.
3.
3, bingo. There's 1, 2, 3 jumps to go from grams to kilograms. So if our decimal place is right here after the 8, we're going to move that decimal place 1, 2, 3 spaces. So when we move that decimal place 3 spaces to the left, what is our new number? What is our new measurement?
0.198 kilograms.
What was that?
0.198 kilograms.
0.198, bingo. So our decimal place is now all the way over on the left because it jumped 3 to the left. So we have 0.198 kilograms. Exactly. So 198 grams is equal to 0.18 kilograms. Very, very good. All right. Any final questions about converting between our different sizes of units?
Yes. For the test, are we gonna have to memorize the table?
No.
Okay.
For the test that you guys will have coming up by the end of the term, you will not have to, because I'll show you where you can find an easy copy of it on the Google Classroom. Good question. So speaking of which, let me go ahead and show you guys where that is at right now. So at the end of the notes here, there are a whole bunch more conversions. If you want to have some where you can look and check yourself on the answer, if you want to do some practice on your own. Like I mentioned to Matt a second ago, when you're going through the assignment that's going to be posted tomorrow, which is all about doing, or for the couple questions that'll be coming up on the test in a few weeks, you can find a copy right where you find the notes that we went over today. So under chemical equations and SI units on the Google Classroom, there is the section of notes from today, which is Wednesday the 7th. Right here are SI units and conversions notes. So there's the whole slideshow that I just went through with you guys right now. But I also posted a slide of just the ladder. So feel free to open this slide up at any point if you just want to look at the ladder and use that to help you figure out some of the different conversion questions that you may be facing in the future. Oops, that's not the right thing. There we go. So your assignment for today is pretty straightforward. And then the assignment tomorrow is some more work on the conversions. There aren't any conversions in the assignment for today. It's just some basic information about the different units that we talked about. So the first part just asks for each of these measurements, what type of measurement is it? Is it length, mass, volume, or one thing that the homework also brings up is time, which we didn't really talk about because it's the exact same in the metric system as in the American system. We both use seconds, minutes, hours for time. So it gives you the symbol or the abbreviation and asks which type of measurement goes with that abbreviation.
Okay.
The second section of the homework posted today asks
Working.
write down the
I'm
correct
not gonna use it.
symbol or the correct abbreviation
I took her walking yesterday.
or
I got her out.
the
Yesterday was a much better
assignments.
day than it has been the past couple of days.
And so writing down those short 1 or 2 letter symbols or abbreviations for things like milliliter and kilometer and kilogram and seconds, like the amount of time, second, and gram and meter and liter, all that good stuff that we talked about at the beginning of today. And then finally, the last section is some kind of simple, what is the word I'm looking for? Like simple real life examples of where these measurements might be used. So using the liters or kilograms or millimeters answering questions about which unit most correctly reflects the size of a big Coke bottle, or how heavy a bowling ball is, or how much a 1 teaspoon of medicine has in it. Simple questions kind of like that. So that's the assignment that got posted today. Again, since you guys came to the Zoom class today, you don't have to do this in order to earn your attendance. I already got your attendance marked down on my DD&D notebook. So if you don't want to get until tomorrow, that is fine. And then tomorrow's homework is basically just a lot of examples of those conversions that we were doing earlier, AKA a couple minutes ago.
Yeah, shit.
So there's just a whole bunch of different conversions, different values. And you just have to convert from the given value to the new one. So in this first example, from milligrams to grams, or from meters to kilometers, or from centimeters up to meters. So there's a whole bunch of ones of these that might take you a couple seconds at first, but as you get more comfortable with it, you should be able to use that ladder and move those decimal places fairly quickly. All right, so that is what is coming up to finish off this week in terms of assignments. The one about just the different types of measurements that got posted today, and this one that's going to be posted tomorrow morning about converting between our different measurements from bigger to smaller or from smaller to bigger.
So, Mr. Stanley, you said if we got attendance for today that we don't have to do the assignment posted for today, we don't have to do that at all, or?
No, you don't have to do it today.
Okay, that's how I was
You do have to
trying
do it at some point because I am still taking it and I'm going to look at it for a grade, but
Great.
you don't have to do it tonight in order to get your attendance counted. You can
Okay.
do it on Friday or sometime over the weekend if that's
Okay.
better for you. But yes, please be doing.
I just had to make sure. I'm like, wait a minute.
Thank you for helping me clarify. Yes, please do make sure that you do finish all of your assignments at some point during the course of the school week. But on the days that you come to the Zoom meetings, you do not have to finish the assignment that day. You can finish it on a different day if you so wish.
Cool. Thank you for clearing that up.
No problem. Thank you for making me clarify. All right, so I got everybody attended that joined in, so that's very good. Any final questions about any of the metric units or doing the conversions, anything like that?